Welcome everyone in lecture number 11. In this video lecture, we will see some applications of Laplace transform in evaluation of integrals. So let's start by taking one example. Suppose we want to evaluate the integral of the type where the limit is from 0 to infinity, t to the power minus 2t cos t dt. Remember, the limit of integral is always from 0 to infinity. Then only we can solve this integral using the properties of Laplace transform. So if you know the definition of Laplace transform of any function is defined as integral 0 to infinity e to the power minus pt ft dt, right? So if you compare this integral with this integral, you can see that this integral is nothing but it is the Laplace transform of, if you see the function here, what is the function here? Ft. If you take this as e to the power minus pt, then whatever is left is ft. So we can write this as it is the Laplace transform of cos t, where p is 2. The parameter value is 2. So now we evaluate the Laplace transform of t cos t by the properties of Laplace transform. If you know the property of Laplace transform, then by derivative property, when you uh, find the Laplace transform of any function which is multiplied by t, then it is equal to minus d over dt Laplace transform of cos t. So this is equal to minus this is d over dp, because when we find the Laplace transform, this will be a function of p. So we differentiate it with respect to p, not with respect to t. So this is p upon p square plus 1, where the value of p is 2. We substitute this value at the end, not in the beginning. Otherwise, you will see that derivative will become 0, because this will become constant when you put p is equal to 2. So you put the value of p at the end after finding the derivative of this function. Okay. So the value of integral 0 to infinity t to the power minus 2t cos t dt is minus d over dp of p upon p square plus 1. And we write in the outer bracket that p is 2. So first we solve this inner bracket. So its derivative would be, by division rule, let me draw the straight line. It is, we have p square plus 1 whole square here, and p square plus 1 into derivative of p, which is 1, minus p into derivative of p square plus 1, which is 2p. This bracket is upon the whole expression. This is p square plus 1 minus 2p square, p square plus 1 whole square. So this is equal to p square minus 1 after taking this negative sign inside the bracket, p square plus 1 whole square. where the value of p is 2. When you substitute p is equal to 2, this is equal to 3 upon 25. Okay. So this is the value of integral that was from 0 to infinity t to the power minus 2t cos t. Let me take second example. Evaluate integral 0 to infinity e to the power minus t minus e to the power minus 3t whole divided by t dt. Now you can separate these terms as well, then solve separate integrals, or you can take this whole as one function. So if we take this as whole ft, this whole ft अगर हम इसको पूरे को एक फंक्शन एज्यूम करें, then the given integral is nothing but this integral can be written as this is equal to 0 to infinity e to the power 0 t ft dt ऐसे लिख सकते हैं हम इसको. So this is nothing but Laplace transform of ft, where the value of p is 0. So now we find Laplace transform of ft. It is Laplace transform of e to the power minus t minus e to the power minus 3t whole divided by t. ओके. अब आप इसमें ft divided by t की प्रॉपर्टी यूज करेंगे. So it is equal to integral p to infinity. ft is in the numerator. It is Laplace transform of e to the power minus t minus e to the power minus 3t. When the function is divided by t, its Laplace is this. And here we have dp. This is equal to integral p to infinity Laplace transform v to the power minus t is 1 upon p plus 1 minus 1 upon p plus 3 integration with respect to p. Don't forget to put p is equal to 0 at last. This implies Laplace of ft is, when you integrate 1 upon p plus 1, it is log of p plus 1. And when you integrate 1 upon p plus 3, it is log of p plus 3. Then we apply limit from p to infinity. So these two log terms can be combined and can be written as log p plus 1 upon p plus 3 by the property of log, where p is 0. So now we take limit p approaches to infinity, log of, always when you have limit in the form of infinity, you take the limit. Don't directly put infinity in the expression. At lower limit, we have the same expression. So you divide the numerator and denominator by p and then put the limit. You will get here log 1, and log 1 is always 0, and this is log of p plus 1 whole divided by p plus 3. Because of this negative sign, the numerator and denominator will exchange. It is log p plus 3 whole divided by p plus 1. Now we put p is equal to 0. We will get Laplace of ft as log 3, and our integration is nothing but Laplace of ft, and p is 0. So we have substituted p is equal to 0 in Laplace of ft, it is log 3. This implies integral 0 to infinity e to the power minus t minus e to the power minus 3t whole divided by t dt is equal to log 3. Example number 3 is evaluate integral 0 to infinity sin t divided by t dt. इसमें भी हम इसको पूरे को एक फंक्शन मान के सॉल्व करेंगे. तो we take ft as sin t whole divided by t, then integral 0 to infinity sin t divided by t dt can be written as integral 0 to infinity e to the power 0 t ft dt. So when we compare it by the definition of Laplace transform, it would be equal to Laplace transform of ft, where value of parameter is 0, parameter p. You can give reason here because Laplace of ft is equal to integral 0 to infinity e to the power minus pt ft dt. So we have to find the Laplace transform of ft, and then we substitute at the end p is equal to 0. Laplace of ft is nothing but Laplace of sin t divided by t. Here we apply the property of ft divided by t, that is equal to p to infinity Laplace of sin t dt equal to p to infinity Laplace of sin t is 1 upon 1 plus p square dt. Okay. So this is equal to tan inverse p. We apply the limit. This implies Laplace of ft is tan inverse p to infinity. This is equal to limit p approaches to infinity tan inverse p minus tan inverse p. This is equal to pi by 2 minus tan inverse p. This is equal to cot inverse p. Putting p is equal to 0, we get Laplace of ft is equal to cot inverse 0, and cot inverse 0 is pi by 2. So this is the answer. You can try some more questions for your practice. For your practice, you can try evaluate the integral 0 to infinity cos 6t minus cos 4t whole divided by t. You can try this question. You can also try this question, but this is not related to evaluation of integrals, but it is the Laplace transform. Find the Laplace transform of 2 1 minus cos hyperbolic 2t whole divided by t. I'll share the answers of these two questions in my next lecture. Okay. Thank you so much. If you liked my lecture, please share it, press the like button, and please subscribe my channel if you have not subscribed it yet, so that you can get the notification of any new video on Laplace transform. Thank you so much.